Okay, we're looking at the casino game called Craps, and basically what you do is you get two dice and you roll them and you add the numbers together. You're rolling two dice, and if you get a total of 7 or 11 on the first roll, you win. And if you roll a 2, 3, or 12 on the first roll, you lose. But if you roll these guys, then you get to roll again. You get a point, and then you have to roll the dice again and try and get that point before you roll a 7. So, yeah, anyway, that's basically what it is. And so Simon, he goes to the casino and he plays 100 times and he records all his rolls. And this is what we got in this display here. Good on you, Simon, for sharing that. Makes it easier for us. So it says down here, use Simon's results on this particular night to estimate the probability of winning a straight game of craps in one roll. So that means in order to do that, we compare it. We got to get a 7 or 11, right? So let's do that to start with. And so that is just going to be the experimental probability, isn't it? So the experimental probability is, well, he gets a 7 20 times out of 100 and he gets an 11 4 times. So that is 24 out of 100, which is 24%. Great. Now, for the theoretical probability, when you're doing two things, the best thing to do is a table like this, and you can see here that I've got that's dice 1 and dice 2, and you just look 1 and 1, 1 and 1 is 2, and 4 and 5 is 9. So you're just adding the dice together. Very easy, but easy to forget the lattice diagram or grid there. So for me to get 11 or at 7, so 7 I've got 1, 2, 3, 4, 5, 6, and oh hello, they're not right. Those 11, 11. So and to get 11 we get it two ways, right? So we've got 6 plus 2 is 8. So we've got, so then my theoretical prob equals 8 out of 6 times 6 is 36, and that gets me to 0.222, which is 22.2%. And you compare, it's pretty similar, very similar. That's just an achieve there for that. All right,